Renewable chemicals and green chemistry represent a transformative approach to how we produce and utilize chemicals in our everyday lives. As we face the pressing challenges of climate change, resource depletion, and environmental degradation, these fields offer promising solutions that not only aim to reduce our ecological footprint but also enhance the sustainability of our industrial practices. The concept of renewable chemicals refers to chemicals derived from renewable resources, such as biomass, rather than from finite fossil fuels. This shift is crucial because it aligns with the broader goal of transitioning to a circular economy, where waste is minimized, and resources are reused effectively. At the heart of renewable chemicals is the idea that we can harness the power of nature to create valuable products. Biomass, which includes materials like plants, agricultural residues, and even waste, serves as a feedstock for producing a variety of chemicals that are traditionally sourced from petroleum. For instance, sugars derived from corn or sugarcane can be converted into bio-based plastics, solvents, and even fuels. This not only reduces our reliance on fossil fuels but also helps in managing agricultural waste, turning what would be discarded into valuable resources. The process of converting biomass into renewable chemicals often involves a combination of biochemical and thermochemical methods. Biochemical methods, such as fermentation, utilize microorganisms to break down biomass into simpler compounds. This process is akin to how yeast ferments sugars into alcohol, but it can also be applied to produce a range of chemicals, including organic acids and alcohols. On the other hand, thermochemical methods involve the application of heat to convert biomass into gases or liquids, which can then be further processed into desired products. Both methods highlight the ingenuity of green chemistry, which seeks to minimize waste and energy consumption while maximizing efficiency. Green chemistry, as a discipline, encompasses principles that guide the design and implementation of chemical processes in a more sustainable manner. It emphasizes the use of safer chemicals, the reduction of hazardous substances, and the development of energy-efficient processes. One of the key tenets of green chemistry is the idea of atom economy, which suggests that chemical reactions should be designed to maximize the incorporation of all materials used in the process into the final product. This principle not only minimizes waste but also enhances the overall efficiency of chemical production. Moreover, green chemistry encourages the use of renewable feedstocks and the design of chemicals that can degrade safely in the environment. This is particularly important in today's world, where plastic pollution has become a significant environmental concern. By developing biodegradable plastics from renewable resources, we can reduce the accumulation of plastic waste in landfills and oceans, thus protecting ecosystems and wildlife. The innovation in biodegradable materials is a clear example of how green chemistry can lead to practical solutions that benefit both industry and the environment. Another fascinating aspect of renewable chemicals and green chemistry is their potential to drive economic growth. As industries shift towards more sustainable practices, there is a growing demand for bio-based products. This trend not only opens up new markets but also creates jobs in sectors such as agriculture, biotechnology, and manufacturing. By investing in renewable chemicals, we can stimulate local economies and promote sustainable development. The transition to a green economy is not just an environmental imperative, it is also an opportunity for innovation and economic resilience. In addition to economic benefits, renewable chemicals and green chemistry also have significant implications for public health. Traditional chemical production processes often involve toxic substances that pose risks to workers and consumers alike. By adopting green chemistry principles, we can minimize exposure to hazardous chemicals and create safer products. For instance, the development of non-toxic solvents and safer alternatives to harmful chemicals in cleaning products and personal care items can lead to healthier living environments. This focus on safety and sustainability resonates with consumers who are increasingly aware of the impact of their choices on health and the environment. Furthermore, the integration of renewable chemicals and green chemistry into education and research is vital for fostering a new generation of scientists and engineers who are equipped to tackle the challenges of sustainability. Educational institutions are beginning to incorporate these concepts into their curricula, encouraging students to think critically about the environmental impact of their work. By engaging in hands-on research and development projects focused on renewable chemicals, students can contribute to real-world solutions while gaining valuable skills that will be essential in the workforce of the future. Collaboration across sectors is also crucial for advancing renewable chemicals and green chemistry. Partnerships between academia, industry, and government can facilitate the sharing of knowledge and resources, leading to innovative solutions that drive sustainability. For example, government incentives and funding can support research initiatives aimed at developing new bio-based materials, while industry can provide practical insights into the scalability and marketability of these products. By working together, stakeholders can accelerate the transition towards a more sustainable chemical industry. Despite the many advantages of renewable chemicals and green chemistry, challenges remain. The scalability of bio-based production processes is often a concern, as transitioning from small-scale experiments to large-scale manufacturing can be complex and costly. Additionally, there can be competition for land and resources between food production and biomass cultivation, raising ethical considerations about how we utilize our agricultural systems. Addressing these challenges requires a holistic approach that considers the interconnectedness of ecological, economic, and social factors. Moreover, consumer acceptance plays a significant role in the success of renewable chemicals. While there is a growing awareness of sustainability issues, many consumers are still hesitant to embrace bio-based products due to perceived higher costs or skepticism about their performance. Education and outreach efforts are essential to inform the public about the benefits of renewable chemicals and to demonstrate that these products can meet or exceed the quality of their conventional counterparts. In conclusion, renewable chemicals and green chemistry represent a vital pathway towards a more sustainable future. By harnessing the power of renewable resources and applying the principles of green chemistry, we can create a chemical industry that is not only more environmentally friendly but also economically viable and socially responsible. The transition to renewable chemicals offers numerous benefits, including reduced reliance on fossil fuels, enhanced public health, and new economic opportunities. As we continue to innovate and collaborate across sectors, we can pave the way for a greener, healthier planet for generations to come. Embracing renewable chemicals and green chemistry is not just an option, it is an imperative for a sustainable future.